Good evening, everyone, again, and I hope you are doing good. Okay.
Hello, everyone. So I think we can start.
Well, can you wait a minute, Ayman? I'm just going to present a few things, and then
Okay.
we're going to start, okay?
Okay.
So, welcome, everyone, to our Tech Plus second event. I am Amina Hal. I am a second-year operations research student at USDHB. I am also a member of the game development section by the GDSC. I know maybe some people are new here, they don't know what DGDSC is. So, DGDSC is basically a nonprofit organization led by passionate students about tech, where we just present and organize various tech activities. Tech Plus is one of them. And Tech Plus is just an online event that takes place every 2 weeks, where we present a modern technology. And for that matter, we are going to present artificial intelligence. We have with us today Aymen Berriche. Welcome, Aymen. And yeah, you can start now. Thank you.
Thank you. So I think we're ready to go. Today's talk will be about demystifying artificial intelligence field. So you can expect from today's talk to learn more about what is AI, more about the subfields of AI. So you'll learn more about what is machine learning, what is deep learning, what is reinforcement learning. Um, so this is like the modern subfields that are really actively uh, uh, in resource field or in the applied field. You'll also learn more about use cases and more also about different jobs that you can pursue in the artificial intelligence field. So we'll start by first of all introducing myself. So my name is Aymen Berriche. I'm a third-year student at Easy Algiers. I'm a GitHub campus expert, also a GDG Algiers development co-manager, and an open source contributor. Um, so let's talk about what we'll talk about this today. So first of all, we'll try to introduce AI from like a general perspective. So what is from where it all began. We'll see some examples and use cases of AI in our daily life, and we'll take a look at most important historical moments. Um, so we also talk about the AI typology. So obviously the modern one, machine learning, deep learning, and reinforcement learning. We'll also try to talk about the state of the art. So I selected three, I would say, architectures and models that are really making a big change in in the modern AI, which is generative adversarial network (GANs), the incredible Microsoft model GPT-3, and finally we'll talk about this natural language, natural language model or architecture, which is transformers. So finally, we'll also tackle the career paths in AI. We'll talk about career path in engineering, in research. Also, we'll talk about the skills required to take or to pursue a career in either one of them. So the first question that humankind asked to really provoke this I would say the research and all the advancement in this what we call today artificial intelligence is this simple question: can machine think? This question was first this question was first asked by Turing. Turing, when in his paper, the imitation game, proposed to consider this simple question: can machine think? So from this question, the artificial intelligence field began to develop, and we came across when and humans became to invest more time to discover new techniques to imitate human intelligence. So some of the question he asked first is what is intelligence and how can we measure intelligence. Finally, he also mentioned about how can we imitate the human intelligence. These three questions remains unsolved into even today. So today we do not have like a specific definition of what is intelligence, or we don't know like a specific and precise manner to measure intelligence. And also we cannot imitate fully the human intelligence or the human brain. But advancement in AI, so a big advancement, and a lot of companies and are really using modern research advancement to apply them into their tools, or build new tools, like the famous Google search. Google search do use a lot of AI. For example, it uses AI to generate suggestion for you. It also uses AI to give you relevant results. Here, for example, you could see before using AI, Google was actually uh, given some relevant results, but not really an authentic one. For example, here the person is searching about is visa required for Brazilian people to go to USA. For example, here it has requested some relevant result, which is a blog post, but the authentical maybe search result that we are searching for is some, for example, for example, when using AI, we suggested the US Embassy website, which is more authentic source of information. AI is also highly used in translation. Translation, we know translation is really important nowadays because of we use it a lot for communication, and we're in a world that communicates in different languages. We do really need translation. So translation uses what we call natural language processing to process human language and try to do different tasks on it. For example, here we do translation. Um, there's also something that we do use all the I would say everyone uses, and which is assistant. Here, for example, Siri uses a lot of AI. Siri, which is the personal assistant for Apple devices, it uses a lot of AI actually. First of all, it uses AI to detect voice. It uses also AI to what we call to understand, first of all, to convert what frequencies into sequential data, which is data that a human could understand. So this is what we call natural language understanding. Then we try to process this data and try to generate a response to what the human has said. So this is what we call natural language generation. So here, for example, assistant uses a lot of AI. Let's talk now about AI historical moments. The first really moment that shocked the world um, and really it has lived like a big it was really a big advancement in AI was back in 1997, where IBM Deep Blue beat Kasparov, which is the world champion in chess game. So IBM used AI to actually not really it's not really the AI that we know today. The AI back then was really what we call computational power. IBM actually used their computational power to actually what we call brute force. So for people that don't know that do not know what is brute force, but brute force actually to try to see the all different uh, uh, possible I would say moves that we can take, and for every move we will try every move and see, and we'll try to pick the best move, so, or the most promising move. This is actually what Deep Blue have did to beat the world champion of chess. But this was easy for the chess game, because chess game is a game where the search game for chess is not really big. So the different for every position, the different moves that we can take are not that big. So with a big computational power, we could try all of them and take the best move. So this is not really. It wasn't really. Even in if we take, for example, in modern if we try to, if a person tries to do the same today, it will be really easy because we have more computational power. The more impressive, I would say, but let's see the video before going to Go game.
Well, Ayman, is this the same program as the chess game in PCs?
Actually, no. Chess game in PCs uses what we call game theories. It's part of AI actually, but it uses different algorithms. But
Yeah.
what Deep Blue used is really like a full demonstration of computational power. So they have like big servers. So they
Yeah.
use their big servers to try all different outcomes and choose the best one to beat the world champion.
Mhm. Yeah. It's pretty impressive, actually.
Yeah, I would say let's go now to a more impressive historical moment for AI, which is AlphaGo of Google DeepMind, who have demonstrated like uh, really impressive win against the world champion of what we call Go game. So what is Go game? Go game is really a big game in Asia, in countries like China, Japan, and South Korea. It's actually a more complex game than chess. It is actually 1 million trillion and trillion more complex than chess game. So you could say that for every position in game of Go, the different moves that you can take tends to infinity. And here you cannot really apply what IBM did, which is try to compute uh,
Yeah.
take every possible move and compute the probability for every possible move. So here what Google did with their AlphaGo is, instead of brute forcing, they use deep learning to reduce the search space. So for every move they tried to uh, have a prediction on how likely this move would guide us to the win, and they have used reinforcement learning to actually learn how to play Go. So obviously, before really doing anything, their model do not know anything about the game. He does not know the rules of the game, how the game is played. So he learned everything from zero. And this is pretty much
Mhm.
how we humans actually learned. From when we are born, we do not really know anything about human life. We do not know anything about math, about how we eat, how we do various things. So actually reinforcement learning is a good way to mimic human intelligence. um, so we'll talk more deeper later about reinforcement learning. So next, they also used some OR heuristics to optimize their computation, obviously. So what we could take from this is the modern AI actually tries to use various techniques to achieve state-of-the-art result, and this is what completely opposite of what we had used before. So next, now we'll talk about typology of AI. So let's talk first about the classical or the old-fashioned one. So artificial intelligence was composed of what we call machine learning. It involves a lot of statistics. So there's statistical learning. There's obviously deep learning. And there's other fields that are not really relevant today. The research today is not very active on those fields, like expert systems, cellular automata, and neural symbolic systems. Instead, modern AI highly focuses on actually neural networks, reinforcement learning. There is also machine learning is also really active. We have also what we call in our modern, I would say, the modern field of AI calls data science, which is not really AI, but there's a big intersection. Data science is more of a statistics on data manipulation, data analysis, and everything. But there's quite good big intersection between the two fields. Um, so let's begin to introduce machine learning. So what is machine learning? Actually, we define machine learning as using algorithms and statistical models to analyze and draw inference from patterns in data. So what does this mean? Actually, machine learning is simply using what we do in machine learning is we simply use statistical tools to first of all do some computation on data. So first of all, we need data. Without data, we cannot really do anything. So with statistical tools, we try um, to search or to try to what we call infer from the data some patterns. So this is what we can refer to pattern as simply some. So we can have a good example here. Yeah. So for example, you could, for example, here you could see this line as a pattern where these two different classes are different. So this is a pattern. Also, drawing this line is considered as a pattern. The pattern. What is the pattern? The pattern is that all training examples are following something that we are trying to know what is it. So we'll talk more in depth about this later. So first of all, let's talk about the pipeline, the machine learning pipeline. First of all, we'll try to collect the data. So obviously, as I said before, without data, you cannot do anything. So when we have enough data, we will pre-process data. Here the data scientist role is highly valuable. So a data scientist will try to clean data, clean also or handle the missing values in data. Um, then when we have a clean data, we'll try to choose an algorithm to process our data. So there's a lot of machine learning algorithms. Uh, so it will depend on your task, the task that you want to do. Either you want to classify, for example, you have the data and you want from your data to infer. For example, you have images and you want to predict if an image is if there is a dog or a cat in your image, for example. So depend.
Can you explain to me what can missing values be or clean values? Like how can data be missing or clean?
Okay, so the thing that you need to know is first of all how we are collecting the data. The
Okay.
collection of data is, for example, I'll give you a simple example, is when you are browsing through websites using your phone.
Yeah.
Actually, the website uses what we call cookies. Cookies, actually, what they do is they are collecting some data from you. If you click, for example, on something, or for example, you have searched for, I don't know, you have search for example, a movie. He can, for example, the cookie could retrieve the type of the movie you have searched or you have watched. Then he we this is like a type of data. For example, then we will use this data to to build the
Suggest and
mode.
refer.
They are using, yeah, they are using this data to build a model that, for example, suggests you something that's relevant for you. So this is an example. But we have to know that when we are doing this, things do not always work when we are collecting data. So sometimes when data is collected, for example, we miss there's some categories that are not filled. Another example that you will is better, I think, when filling a form. When filling a form, we actually do collect a lot of data by filling forms. When filling forms, a lot of because it's a human who fills the form.
Yeah.
Uh, there's a lot of cases when fields are not filled, for example,
Uh-huh.
or
So
are filled. Or yes, human also could fill this with
fields in the wrong
for
way.
example, if you are requesting like an age, he could give you, for example, a text, and
Yeah,
this is
exactly.
considered as yeah, as like not clean data.
Uh-huh, yeah, I
So
got
we
it.
have to
Thank
handle
you.
it.
Yeah. Thank you.
Uh, okay, so then when we have a clean data, we could move on to choose an algorithm. So as I said before, the algorithm would depends on the task you're trying to achieve. For example, you're trying to do a classification. For example, you have images and trying to classify if an image is there is like a dog or a cat in image, for example. Uh, then when choosing an algorithm, you could train your model. So what is training model is simply given the data to the algorithm, and the algorithm will do a lot of iteration, and in each iteration it will try to its parameter update its parameters, and finally when finishing finishing with training, we actually have to test our model. Why testing? Because actually what we did in the training process is we have given the model some data, but we don't really know if the model has learned actually to predict, or simply um, what we call overfitting. It's actually what we say حنايا نقولوا بالعربية يحفظ يولي يحفظ. For example,
Mm,
حنا we want to our model يولي يفهم, but model يولي يحفظ. For example, here for test set, if we test on different data, it will perform really bad.
well, while training the model, like الموديل مدولو des instructions, après هو يقعد يعاود فيهم ولا ما فهمتش كيف
Okay,
البروسيس
so
يصرا.
first of all, so the model it will be initialized with random parameters. So, for example, for each algorithm, we will give it the data, and for every algorithm هيكون عنده the parameters. So it will have parameters, and these
Mhm.
parameters would be randomly initialized and then we'll have some iteration, a lot of iteration. What is an iteration? It's like a complete pass on the data. Each time we go for in شغل نروح ونجوز على الداتا تاعنا, and for each pass we'll try, for example, there's obviously each algorithm كيفاه يمشي, and for each pass on our data we'll try to update our parameters. So
Exactly.
yeah, so in the final result we'll have like an optimal parameters. These parameters will help us when seeing, for example, when trying our models, when given, for example, an image without really redoing the training. with a sample, for example, with a sample function that will, for example, for a classification problem, will return either a 0 or a 1. If it's a cat, it will return a 1, or if it's a dog, it will return a 0. So there's no need to redo the training because we have our optimal parameters. So
Okay.
this is where test is really important. Testing your models, actually using a test set. So what is a test set? A test set is like a data. So when we are collecting the data, for example, we have 100% percent of our data, but when training model, I would say I will give it just 18%. So, and the remaining I will leave it for test set. So when doing the test set, the data that I have in test set, the model, my model when training, when training the model has never seen it. So I actually have like a good metric to see if my model is actually learning and not really as I said before, really يحفظ. So
Yeah.
here, if like for example, my model is doing great on my test set, then I could be satisfied maybe and deploy my model. For example, if I have a mobile application, I could deploy my model and use it. Um, then if I want to have a better accuracy, my model, if I want like a better accuracy, I could maybe collect more data and redo the training, so training on more data. Or if I have, for example, overfitting. What is overfitting? Is simply, as I said before, الموديل اللي يحفظ. So key model اللي يحفظ, you have to go to the training process and see what you have to change. Maybe having less data could solve the problem, or better like choosing another learning algorithm, for example. So there is a lot of techniques to solve this problem, and this is really like a really known problem in the machine learning field. So let's talk now about supervised and unsupervised learning. So what is first of all, what is the difference between supervised and unsupervised learning? When talking about supervised learning, is actually when having my data, I know for every data if it is, what is the nature of the data, or what is the label of the data. For example, here's my data when plotting it. Here for every data, if I consider the red crosses as, for example, a cat, and the blue circles as a dog, I know for every single example of my data if this is a dog or a cat. And the role of, or the objective of my machine learning model is to, for example, draw here a line and say, when above this line, I will consider I will consider all the examples, or all the data as dogs, and below this line, I will consider all the data as cats. The unsupervised learning is the complete not complete opposite, but we do not really know for each example the nature or the label of the data. So here we do not know if this is a cat or this is a dog, or same thing for those. So the role of of the machine learning algorithm is to cluster. So what we say cluster, so شغل يجمعهم يفرقهم, and say, this is the first cluster, this is the second cluster, but I don't really know what is this and what is this. My simple objective is to cluster them. راح نجمعهم لك, and you have to interpret what is this and what is this. Okay. Is this clear for this one?
Well, I check the chat if there are any questions.
Okay, so we can
Yes,
go
it
back.
is.
Yeah.
Yeah, it
Good.
is.
Okay, so there is also something to clarify in machine learning, which is classification and regression. So there's two types of I would say problems in machine learning. Either we want to do classification, and or we want to do a regression. So first of all, let's understand what is classification. First of all, here we have, for example, our data. Our data is plotted, for example, here, and we have, for example, two classes. You could see these classes as I said before. This is the class A, or class of dogs, and class B, or class of cats. The role of my model is to simply try to separate between those. When separating between those is actually fitting a function. This is simply a function that we are trying to fit. As I said, as I have gave the example for example, randomized. When we are starting to train, we'll randomly initialize our the parameter of our algorithm. Here, for example, the first initialization of our function could be like a line drawn this way or this way, and for every iteration, for example, we try to compute the distance between every single example, and for every and the function and our function, and for every iteration we'll try to update the parameter of our function, and finally we'll have a function that actually separates between these two classes. The thing that you need to know when doing classification is we are not really obliged to draw like a straight line. This is called when we are plotting a straight line. This is called linear regression, something linear. But instead, we could draw something like this, and the line is not really straight. This is what we call polynomial regression. Um, and you also need to know that in the final result, we will not have all of our classes in classified right. And this is normal because when handling like real world data, we could have really a lot of special cases. When we have in, like, if you gave you example, for example, I don't know, for example, if we take this salary and experience, for example, we could have something like a training example will be standing just right here, having like a low experience and a lot of salary. This could be, for example, a special case for a rich person, for example. He has like a little low experience and he has a lot of salary, and maybe a person who has built like a startup and become a millionaire, for example, he has little experience and having like a lot of salary.
Yeah, someone with rich parents too. Yeah.
Yeah. This is what we call special cases, for example, and therefore, like we will expect having like when in our final result having what we call misclassified examples, and this is completely normal. Talk now about regression. Regression, it's not really we're not really trying to classify, but we are trying to predict. For example, here we are trying based on experience, for example, trying to predict the salary. So this is the objective of our model. I will try to give him experience, and he will say or try to predict what is the salary for this experienced person. And this is what we call regression. So in the data, it will be, if we plot the data, it will be it will not have like classification. It will not have classes, and our objective also to draw a line that will best fit this data, so as to minimize the distance of every training example from our line, and if we try to predict, we'll simply project, for example, this experience, for example, having 8 years of experience, we'll project and see what the estimated salary. And this is a really basic regression problem. If we see like more advanced or algorithms like random forest or k nearest neighbors. It's the same, I would say, same logic, but more complex and also more effective models. So there's these two paradigms in machine learning: classification and regression. I hope it's clear for these two.
Oh, so this line that is drawn in the graph is the result of the trained AI, right?
Yeah. So basically, what we do here in training is first, as the classification example. First of all, the function will be randomly initialized, and for each pass on the data, we'll try to compute, for example, the distance uh, for each example from our line, and the objective is to minimize the distance so as
Mhm.
to fit the best our data.
Okay. Do you have guys any questions? Anything not clear? I think it's all clear. Yeah,
Uh,
you can
yeah.
continue.
Yes, the thing to you have to know is this is really like I would say really a lot. There's a lot of statistics here and a lot of probability going on machine learning. When we try to talk about deep learning, you'll see that really another there's really another way of thinking. It's really totally different from machine learning. So obviously there's also the training process and everything, but
Yeah,
there's less and less, really less of statistics.
yeah.
So let's talk about deep learning. So we define deep learning as a subset of course, of machine learning, where artificial neural networks, algorithms based on the structure and functioning of the human brain, learn from large amount of data to create patterns for decision making. So obviously, before talking about deep learning, the thing I want to, I always like to do is ask why we do we need deep learning. Actually, we have really good results with machine learning. Why the need for a complete different structure, complete different paradigm, complete way of thinking? So the thing that you need to know is, for example, here one it's totally depends on data. For example, here uh, we plot the amount the for example for the amount of data and how much performance we can get. For example, for machine learning, traditional machine learning, we as I said before, the more data we have, the best our model will work. But at some point, no matter how data you have, your machine learning model will obviously not give you better result. And this is what really pushed us to see something new, to try different things, and come up with a different way of thinking, and also uh, like an architecture that will use the data and will profit from having a big amount of data. So for deep neural networks, the more data you have, the better result you have. And this is the difference between machine learning and deep learning models. So especially in our modern days, where we have a lot and enormous data because of what social media, because of different techniques that we are using in web to retrieve data, because also of the highest amount of people using the internet, we could have a lot of data. So this has really pushed us to try different things and come up with what we call the artificial neural network. So s- the structure of the neural networks are highly influenced by the biological neural network, our human brain neural network. For example, here you could compare the cell body with what we call a unit, a unit in the artificial neural network, um, and different connections between them, what we call synapses. As you can compare it to different connections between these hidden units. So in the artificial neural network architecture, the external layers are called respectively input layer and output layer. The hidden layers are called simply hidden layers. And for, you could imagine, for each unit, it's simply like there's a mathematical formula that is doing it has obviously a purpose. Uh, this, if we are trying to for example predict if an image it's a cat or a dog, for example, this hidden unit, it will have as purpose as to give more information about for example the shape of a cat, for example. Well, we'll here we'll see more in depth. We'll have more, I would say, intuition about how neural network works. For example, this sample, I would say, example about how housing price prediction. We have some size of a house that we are trying to we have a size of a house and trying to predict price. For example, here we could, if we are using machine learning, we could simply draw this line and have like a good results. Here, for example, I would say machine learning works better. But if I gave you like this more informations, like size of the house, number of bedrooms, for example, the zip code where the house is situated, for example, the wealth, for example, the if the par exemple la cité وين كاينه la maison هذيك, if it's really like a high it has a high reputation or not. So we have, for example, this a lot of a lot of informations. Here we could really use what we call neural networks, and have, for example, here as an input in input layer, we input in the input layer, we'll try to give it, for example, the number of bedrooms. We'll try here to give it the size, the wealth, and the in this hidden layer, thanks to the computation it's doing here. For example, we would have this hidden unit will tell us more about I don't know, like if you like something that will involve number of bedrooms and size, for example. And here we'll have other information that will involve, for example, zip code and wealth, for example. So you have to imagine every hidden unit with a specific information that it will tell you, and everything when in the output layer, when we add everything, we could, for example, have a function that will output the result for us. For example, here we are trying to predict the price of the house. So based on these different information, we could combine them all and output the price of the house. It's how it's different from machine learning. Here we're not really using a lot of statistics. It's more of an algorithm and specific. It's an algorithm and math going on in these hidden units and hidden layers computation. So there's not, like machine learning, a lot of statistics going on. But obviously, this is like the basic, really basic structure of a neural network. We have more and different structure for every application. For example, if you're trying it in computer vision, for example, if you're trying to, you have images, there is a more suitable architecture. If I can give you example here, what we call CNN or convolutional neural network. So this architecture is more it's more distant for images, for example. It's totally different from neural network, but there's always the same. I would say the same part that we are in the same, I would say, structure of having hidden layers and external layers. So the thing to keep in mind here is this is really simple, the simple structure, and for each task we'll try to adapt this neural network to the task that we are trying to do. So I don't know if there is any question or
Is everything clear, everyone? So basically, what a neural network does is just it takes inputs and merges them according to a mathematical formula. Is that it?
yeah, this is
To give you the best approach of the thing you want.
yeah, you can take it as it will basically, yes, as you said, it will do a lot of computation here. So it is what you need to know. It's the same computation that we do here in the first layer between the input layer and the hidden layer, and the, for example, the other two layers. So there's the sum computation. So you can see it as a loop going on. And the other thing that you need also to keep in mind, the more complex the structure is, or the neural network is, the more if, for example, if you have more hidden layers, for example, here we have two, just two. If we have, for example, I don't know, 10, for example, and the more also, for example, here we have three hidden units per hidden layer. For example, if we have also 10, uh, you could expect your model to do better, but it's like data. It's not really it won't really work. It won't always work. So you have to try different things to have better accuracy.
Okay, so the whole neural network has a formula, or there is a formula between the first and the second hidden layer, or yeah.
It has a formula actually. The formula is the same for every two couples of layers. So if this is what we in the algorithm they call this a forward propagation. It's like you have your data, it will propagate through all layers. So in every layer it will do the same thing. Obviously the last layer won't do the same thing, because the last layer is expected to give information which is representative to the task that you wanted to do. For example, you want to achieve, for example, here we want to predict the price of a house. We are expecting our output layer to give something which resembles like a price,
Yeah.
not a probability. For example, if we're trying to I don't know, to classify, maybe we are expecting our model or our output layer to give us something like a 0 or a 1. For example, if we have like three classes, a 0, 1, and 2. So this is we do this, for example, by known functions. For example, I'll give you just a like an example, is what we call sigmoid function. uh, um, so this is a simple function. I don't know if we could. Yeah, this is like a sample function. The characteristics of this function, it will give you values between 0 and 1, and we use it to when we are trying to, for example, trying to have prediction. For example, I give you, I don't know, for example, I give you like images, and for images, I want to know the what is the prediction to have, for example, what is the prediction, for example, to have a cat in an image, for example. And so I always expect my output to be to be a probability from 0 to 1. So this will help us to convert our numerical values to values between 0 and 1. And there's a lot of functions that will help us to adapt our values to the output that we want to have.
Okay, thank you. That was very clear. We have some questions in the chat. Well, Yeni said, so does the last year layer use a different formula?
Yeah, as I said before, the output layer would yes, it will use a different formula. Depends on the task. For example, as I said, if I want to have a probability as output between 0 and 1, the last layer would be simply a function, the function that I have shown you before, this function. If I wanted to, for example, to have like I want to classify, so I want to have a 0 or 1, I will use a function that will give me a 0 or 1. Is it clear?
Yeah, it is. Well, there is another question. Hajar said, I'm wondering how to update those data each time. And it's all prediction, so there is a possibility of error.
Let me read the question.
Yeah.
I'm wondering how to update those data each time, and it's all prediction, so there is a probability of error. So in what we actually do is it's same thing as machine learning. We are doing what we call forward propagation. For example, for each data, what we are doing is we are taking the data. For example, here we'll take, for example, for every training example. So I take one house, I have like a data full of houses. I take one house and I'll take the size, the bedrooms, the zip code, the wealth, and I will, for example, for this hidden unit, I will compute something. So there's a function here. There's also a function here and a function here. So each each hidden unit is initialized with a different parameter. This is what will give us different information in each layer, in each hidden unit. So this will be initialized with a different parameter than this, and obviously, I'll try to have the pointer here to make you, for example, here, for example, yeah. As I said, this will be initialized with a different parameter, and this will prevent us of having the same information calculated here and here. So what you want to need what you need to know is for every pass, for every forward propagation. So we'll do the same thing with the other uh, hidden layer. We'll try to have this hidden layer use these three informations to compute another time. And when we arrive in the last output layer, will not simply output, because we need to go we need to go through all the data. So what we need when we are going through one sample training example is to calculate the error. And what is the error is simply the difference on the output, what we have predicted just one time, and the real value. Don't forget, as we have talked earlier, this is a supervised learning example. The supervised learning example, in supervised learning example, we do know the, for example, in our case, the price of the house. So for each training example, we have these informations, and we also have the price. And the price is really important, because it will let us to compute the error. And what is the error is for every forward propagation, when we try to predict for that house its price, we'll try to see what is the error, and what is the error is actually how far we are from the actual value of the house. And based on that error, we'll try to update these different parameters. So the parameter in this hidden unit, this hidden unit, and this hidden unit. So based on the error calculated here, we'll go back to every, so it's, let me, yeah. So we are here, we have computed the error. So we'll have to go back for each layer and try to update the parameter here and the parameter here and the parameter here. Same thing, go back and update the parameter here, parameter here. So and for next training example, we'll do the same thing. We have another house here. We'll try to calculate in each hidden unit. We'll try to calculate the same thing and do what we call forward propagation. In an output layer, we'll output, for example, the price of the house and see how far we are from the actual price of the house, and do the same thing. Based on that error, we'll try to update the different parameters. And the what we call here going back, it's called the back propagation. So we have forward propagation, calculating the different parameters here and having like an estimation of the price, then calculating the error. Based on that error, we'll have to do a back propagation and update the different weight, what we call weight, or you could simply refer to it as parameters. I
Okay,
think
so
is it clear?
well, I have something unclear.
Yeah.
So when the results is kind of far, that is a type of error, right? There are other errors.
The error is simply the distance between your prediction and the
Oh, I thought
actual
that
price.
it is an actual error as
No,
a
and it's
bug.
not. No, it's not a bug. It's actual an error on the. It's an estimation error. Yeah.
So there is no possibility that we have an irrelevant result as not far or
Uh,
something, like totally irrelevant.
in the first pass, when you are first of all, when you randomly initialized your neural network, as I said before, it will be randomly initialized, and you, for the first training example, as I said, you will try to go through your data, and each time you go through your data, try to compute the price. You expect your first estimation to be very, very, very far from the actual price, because the parameters are randomly initialized. And thanks to that error estimation, and we'll try to update our
So we
parameters.
know where the problem is and we update the parameters. Yeah.
Yeah, you could say that our parameters is completely it will guide, you could see the parameters as a guide to outputting the best results. So having the best or the more optimized weights, or what we call parameters, would give us obviously the best price. So when randomly initialized, it's obviously not the best parameters, not the optimal parameters. So obviously you will have a really far estimation of the
Okay.
price.
Yeah. So there is another question. Nazim said, in some cases, can we get two different results with the same initial conditions, like in weather prediction?
It will, yes, it will. I think he refers to the final when we have completed the training. Uh, so when you initialize your model, yes, it will randomly initialized, but it will converge. Obviously, it will converge the same point. If you repeat, like, I don't know, 100 times with randomly initialized weight, if you do not change anything, you do not change your data, you do not change your I don't know, your structure of neural network, it will converge to the same point, and you will have the same accuracy. Um, the thing that you may change is a slight thing, slight accuracy. For example, in the order of 10 to the power of I don't know, -5 or something. So it's really a slight change. It's not really relevant for when you're trying to use your model. The Is it clear, or should I?
Well,
Uh,
is it clear, everyone?
Maybe I should explain why it does converge when you initialize with different because we are initializing with random values, and why it is convergent as each time, because we are really for example, for our data, we are doing a lot. We are going through, it's a loop, and we are going through our data like 10 times, for example. It's what we call a hyperparameter. I could choose how many times I could go through my data. For example,
Yeah.
if I go through my data like 10 times, obviously I will do the same thing, same computation 10 times on each training example, and you will expect like when you arrive like at the seventh iteration, it will know more. It will know more like you won't have like a better result, because it is simply you have like the what we call you have what we call local optima, and there's no room for there's maybe what we call local optima. So you could see it, for example, here. You could see, for example, this is our function, the function of our weight, and for every maybe trying to make it bigger. Yeah, this is, for example, the function of our weight. And for example, for every training example, we are updating the values of this function. And obviously, one if you, for example, in the 10th iteration or the 7th iteration, it will depend. For example, you are here, so your model, it will no longer update its weights because it has the optimal result. This is why so if you start from here, so this is the random initialization. If you start or from here or from here or from here, no matter where you start from, your model will have to end up here to the optimal initialization. This is obviously the objective, but in some cases it may end up here or here, and this is quite like known problem in deep learning. So how can you? The problem is, how can you end up always on the global minimum instead of ending up in a local minimum, or another also minimum, local minimum. So the objective is the optimal result is the global minimum, but you do not know if you will end up there. Is it clear?
Is it clear at this point, everyone? Well, someone said that weights will get corrected in the correction phase, so it will converge into the same results.
Yeah.
Yeah, exactly. Well, Hajar said, on what basis are these parameters chosen, or we chose them automatically?
I think she's talking about the
Deep
yes, the
learning,
parameters.
yeah, yeah.
Yeah, okay. So as I said, the in first at the first time you go through your data, it will be randomly initialized, and then for every iteration, it will get better and better. So first time it will be randomly initialized.
Okay, I think that's it. Thank you. You can continue.
Okay, so we saw this. Okay, now let's talk about reinforcement learning. So we have finished with deep learning. Now we'll try to talk about reinforcement learning. It's totally different from machine learning and deep learning. There is no data here, so we do define reinforcement learning as a subset always of machine learning. Where we are we're training method based on rewarding desired behaviors and or punishing undesired ones. So to understand better, let's take this example. Here, for example, our task or our objective is to learn to make our machine, or what we call in reinforcement learning, uh, what we call here, it's not a machine, but it's an agent. So we have our agent, which is here our player that plays the game of Pac-Man. And the objective of our player is to play better, of course, this game. So in the first time, we do not know anything about this game. What are the rules? What are the environment? What what is like the characteristics of the player? What we can do, what we cannot do. So simply the possible the thing that we know is the possible I would say commands that we can take in game. For example, here in the game of Pac-Man, we could, for example, of the game of Pac-Man, we can go right, we can go left, we can. Uh, so this is a simple commands. So this is the only things that we know in the game, and the objective is to play better. So what we are using here is a technique used rewarding good plays and punishing like bad plays. So if, for example, we'll try to play a lot of games, and each game, if the our player is for example here it is collecting points, he will get reward. Or if he for example get caught by this and loses the game, it will have no rewards, or maybe get punishment. So what we refer as what we are referring by reward or punishment is as as we have seen in deep learning for example, it's simply an update of the parameter of the agent. So for example, if the parameter if he has taken like a good decision and he didn't lose the game, we'll give it a good reward. And this reward is simply updating the parameter of the agent towards making the same moves. For example, if he didn't really do a good job and he lost the game, we will try to update the parameter of the agent, but not in the same. For simply, we'll try to not do the same move again. So we'll try to update the the parameters of the game so as to not make the same decision again. So here we're trying to play a lot of games, and each time we'll try to update the parameters of our agent. So he at the same time he will be really not the same at first time he will be really crap at what he's doing. He'll not really be a good player, but in every iteration he will take he will try we'll try to update his parameters, and he will learn how to play the game. So a good example to understand reinforcement learning is actually it's not really something something that we have invented. It simply comes from uh, not only humankind logic but also for animal logic. For example, we are given it the chicken is doing like something on the paper, on a really specific color of the paper, and each time when she's doing that move, she's given reward. And when the chicken's not really doing the move on the on that color, it's not really given anything. So this is simply a simple application of this logic. Is the logic of doing a good thing, you have rewards. Not going doing or doing a bad thing, or not the wanted thing, you do not have rewards, or you have punishment. Is it clear with the reinforcement learning?
Well, let's just wait.
Yeah, it is. It is clear. Very.
Okay, so let's talk now about state of the art of the field of AI. What do you mean? What do we mean by state of the art? First, state of the art, you can describe state of the art as the most advanced things in the field. Things like models or architectures, as we have, for example. Uh, we have talked in deep learning about neural networks. We have to know that neural networks are really good, but it's not what we call state of the art. They're not really used a lot, but we use a more advanced or more fine-tuned versions of those neural networks. For example, here there is what we call transformers. Transformers is an architecture used in AI nowadays. It's really transforming the world. Everything that involves human language uh, uses nowadays uses transformers, and even we are going further lately. We're even using it for computer vision. So what is those we'll not really go into a lot of into details because it's really something we could do a complete talk on it. So um, it's simply it is simply a model that's made to give really the best result on natural language. For example, here we are using it for a translation. For example, to from English to French. Um, there is an organization called Hugging Face, which is an open source organization that is most known to for its Transformers framework. So, what is this Transformers framework? It actually gives you uh, a complete implementation of the architecture, so you can use it to, for example, to train your models, or for example, it even gives you an API. So what is an API? It's simply you not really have to train a model. You just have to use their models, their trained models, and use it for your application, for example. um, we could, for example, so this is the Hugging Face spaces. So there's a space dedicated for hosting your models. For example, this is a Wikipedia assistant, a model completely built using transformers. For example, we can ask, for example, a question, and the assistant, it will simply answer. Um, for example, it gave us really a really relevant answer to our question: why do airplanes leave contrails in the sky? And also, it will give you, for example, here a voice generation of the text. So you could have really a sense of, for example, how our assistants work. For example, for phone assistants like Siri work. So it really uses a lot of, for example, tools like this to, for example, here we are using this tool to respond to questions. So you could imagine how these assistants are working using this state of the art technology. There's also another model that really changed how we are seeing, how do we see the words and how we imagine the world in future, which is GPT-3. GPT-3 actually uses deep learning to produce human-like text. It's also most known to be used to generate code, and this is really amazing at the same time as frightening, actually, because it is generating actually really good code. For example, here is an example where I try to so it doesn't want to go full screen. Okay, so um, for example, here we're using the model to, um, for example, we are asking it to, with a sample, like a comment instruction to do something to generate code. For example, here he's asking it to sorry, to load for example, a data set to x and y variables, and by simply calling a function, it will actually generate the code. And it did actually what he asked for, to load the data set into x and y. Um, this is actually really frightening because it can really replace not only like things that we um, it can replace actually software engineers, and this is really like frightening. uh, so for example here, he asked to plot a histogram, and it did just that. So this model, it's really a big advancement in AI. It's one of the biggest advancement, but it's actually also really frightening because we went really too far on it. Really went too far on what it can actually do. Um, let's
Well,
also
well,
uh,
is there an estimation of time so programmers lose their jobs?
um, I don't know. It will depend on the type of programmer. I think we'll always need software engineers to, because even this I don't know, the infrastructure and everything is maintained by software engineers. So we do need um, software engineers, but maybe we can do the same thing, and we'll try to automate everything using AI.
Yeah, exactly. It's
So
really terrifying, actually.
yeah.
So if there exists a programmer, it would be a pro programmer. There isn't a basic programmer.
Yeah, maybe, yeah, as you said, we maybe will try to adapt, and
Yeah,
maybe
hopefully.
it would be like another version or another definition of what is a software engineer.
Yeah.
So we'll continue through the state of the art by introducing another type of architecture, a modern one, which is generative adversarial networks.
Are
So
these the pictures we get as we log to sites to confirm that we are robots?
actually, no. The actually it uses it's a different thing, but in when you when the machine tries to verify if you're a robot or not, it simply give you images and try to, and it actually knows for every image if it is the label of the image. If it is asking you
Yeah.
to select buses, he knows, the machine knows where are the buses or not. It's actually not the same thing. So this is also a terrifying thing, actually. This model works on tasks of computer vision. So everything involving photos, videos, and everything. So I will try to explain how it works. So uh, we have two entities in our model. We have what we call a generator and the discriminator. So the role of the generator is actually simply to generate fake images. And the role of discriminator is to differentiate between real faces and generated faces. So the task of the discriminator will be to, it's a simple neural network. Obviously, it will be more complex, but it is a simple neural network, and it will output. It has to output. For example, it is doing a classification task, which is to classify fake photos from real photos. And for the generator, it's actually not doing classification, but it's doing something more. It's something like regression. It's like outputting prices of houses, as we said, we have seen before. But here it's more complex. We are trying to generate faces. So you can imagine we are generating an image, and an image is composed of pixels, and pixels are simply values from 0 to 2055. So it is like outputting process, but it's more complex. So we're trying to generate faces, And so here, in every iteration, this one will try to generate face, will give it real face, and the discriminator will learn how to classify fake faces and real faces. So at our final result, we will have two models actually, and not only one model. We'll have a model that really knows how to generate faces
And
that,
one that detects them.
yeah, and the purpose of the generator is actually when the discriminator says it's fake, he will try to update his parameters and try to the next time generate a face and try to beat the discriminator, so as to predict a real photo.
Yeah.
So we'll have our generator which has learned really to generate uh, generated faces that looks like real faces, and discriminator also will be really strong to differentiate between real faces and random or generated faces. To demonstrate this, there's a quite known website which is actually generating fake images. So the people generated here are do not exist. So this the I'll share the link if you guys wanted to.
That's really scary, to be honest.
It is very scary, actually. Yeah. So you cannot, a human cannot really say if it is fake or not.
Yeah, exactly. I was going to ask you, like, for example, in Japan and such, they have like robots, like in hotels and such, and they really look like humans. And a human cannot really know whether this is a robot or a human. So, do we really need AI to determine whether this is a robot or a human being?
Actually, as I said, for example, if you see these images, a human cannot really differentiate if
Yeah,
it's a generated
exactly.
photo or not. But if we, for example, take the model trained, for example, the discriminated trained on this generator model, he will he will do better on detecting fake humans from generated one than
Yeah,
human. And that's
yeah,
actually really scary because when for example, in various generation of research in machine learning and deep learning, we always have considered as human intelligence is
yeah,
always given better results than artificial intelligence. But really we have never thought that AI could really perform better in these kind of tasks, these like vision tasks, and really something
yeah,
that humans do without any effort. For example, AI, we could expect AI to do better at calculation, for example, because it's powered by a machine that could do a lot of calculation, but not something involved with vision, for example.
yeah. Whoever did this did the wrong thing. Really, really, that's really scary.
Yeah, there is actually a complete field which called deepfake, which
Yeah,
is I don't know, it's called deepfake, and the purpose of this field is to actually generate fake videos and fake voices and fake everything fake.
yeah. What's the purpose if it's fake? Just
Yeah,
to
actually, it's we could use it for propaganda, for example.
ah,
To Yeah, for example, here you could see the president of the United States. For example, you could generate a video that, for example, with his face, like real face, not only photo but video and a voice, his same voice, but completely stating something fake, and you
yeah,
could use it for propaganda and share the video. It would be good. It would go wild, and yeah,
yeah.
it's
Sammy
quite
said,
promising.
or for a movie making for more ethical uses.
Yes, there's actually a lot of ethical like uses of deepfake. but there's also a lot of uses in
But
the
for those
downside.
people who use like other people faces, there is a law, right? That punishes for such. It is a
Yeah,
crime.
yes, of course, it's considered as crime.
But how would they know that this is the real person or not?
No, no. When you, for example, when you use a fake image, if the person does not exist, you're
Yeah,
not really
yeah, I
punished.
mean, when the person does exist and they actually make
Yeah,
things with
but
it.
when you're trying to, for example, make a fake passport of this out of this person, and you're trying to use in it, it's considered as you're taking the an identity that's not yours, and it's still
Yeah,
a crime. Yeah.
exactly.
So we'll try to continue.
Yeah.
Then, is it clear for Gans?
Is it clear, everyone? Do you have any questions? Well, someone said that there are laws being created in the European countries about this concept and a huge discussion about the ethics of AI. Yeah,
Yeah. So
that's
there,
good.
ethics of AI is actually like a separate, complete field. There's like jobs like a separate jobs, which is a ethical engineer in AI. It's a job. So ethical engineers or ethical researchers in AI try to, for example, study for example, this neural network and these algorithms, and try to prevent, for example, problems like gender biases.
Yeah,
Yes. So, for example, AI is really known for gender biases,
yeah,
and this is there's a lot of I would say you could say that data is the origin of this bias. By, for example, if you have like of data that is high biased, then your model, it will be also high biased. So it will only reflect your data. So
yeah,
for example, this is an example that there is a lot of there's other example of biases. So let's talk now about career paths to finish off. So what is like a career in AI? So you could careers in AI could be divided into two. You could expect a career into research or into engineering. So uh, let's let's talk about the differences between research and engineering. As a researcher, you would be expected to use scientific knowledge to understand the world around you and uncover new things. For example, the all the models we have seen previously seen, it was invented by researchers in the field. So researchers are also highly known for trying new things without really a purpose, just for the sake of knowing. Uh, at the opposite, an engineer working in AI, he tries to apply scientific knowledge. So, for example, if there's a new discovery, a new algorithm, a new structure, new architecture, he will try to implement it, try to apply it. So he tries always to solve a problem, or he tries to improve something, or he tries to create some software. So an engineer is always also trying to design new devices and systems that serve a useful purpose, that is not met by any existing technology. So to summarize, the difference between the two is engineers will be he spend more time on implementing actually what the researchers are discovering. Uh,
okay.
so so you can see the field as, for example, you could expect a career as a machine learning engineer or a researcher. You'd also expect a career in deep learning or in reinforcement learning. For example, you could even go further and specialize in deep learning. For example, you should specialize in natural language processing or computer vision. Uh, then always there's also the job of data scientist. She's not really considered as AI, but it has a data scientist does a lot of what a machine learning do, but the purpose of a data scientist is always to handle data, to clean data, to do analysis on data. So
Yeah,
it,
there is still a step of machine learning.
yeah, yeah, it's actually not. It's two different jobs, two different domains. Uh, so so what is actually, let's now talk about skills. What is like skills required for an engineer to for example in AI in general? For example, you are expected to have, for example, a degree in computer science. The thing is, it's not only in computer science. You could have a degree in math or in machine learning, or for example in operational research, or any related field, for example in statistics. And for example and this is really the thing in AI, because most of researcher and engineers comes from really different fields. There's a lot of maths graduates, and fields like even uh, bioinformatics. There's even neuroscience graduate. So it's a field where there's a lot of people from different backgrounds comes together and are united to work on the same thing. You'll be also expected to as an engineer to have experience in programming and debugging, as you'll be really doing a lot of software engineer out there. So you'll also you'll be expected to use or also have a strong knowledge on deep learning frameworks. There is PyTorch, of course, TensorFlow, JAX, and Keras. There's a lot of deep learning framework. So what is deep learning frameworks? It's simply what we have all seen. For example, the neural network architecture, for example, the machine learning algorithms. Actually, when you are trying to build something, you're not really expected to code for example, the architecture or code the different mathematical formulas. There's actually what we call frameworks. These frameworks have already implemented these things. You'll just have to use them to train your models. As an AI engineer, you have to, for example, demonstrate your skills. And open source contribution is a really nice way to demonstrate your skill at some technology. Um, so we'll move on to, for example, a researcher. A researcher is expected to have a PhD degree for example, in computer science, math, or a related field. Or there is also what companies call equivalent proven experience. So when you don't have a PhD or a degree at all, you need to have equivalent proven experience. So there's also a researcher is always does always need to have experience using deep learning framework, because he will be involved in research. He will try new things, and how he will try new things, he will obviously try to implement them and see if it is really working or not. So basically, obviously, he will need a lot of knowledge in frameworks. And obviously, researchers are expected to have a good a publishing record. So they are expected to publish scientific papers at worldwide conferences like NeuralIPS, ACML, and other conferences. So scientific publication is the way to demonstrate your skill as a researcher. So, is there any question
Well, there
regarding this
is a
section?
question in the chat. Well, Sammy said, if you want to generate, let's say, faces, does your data set need to have only faces without any background, or it doesn't matter as long as there is a face on it?
Yeah, it doesn't really matter, because obviously there's techniques to handle those things, like having background. I would go even further. For example, you're trying to predict if there's, for example, a cat in an image, but this image has like a lot of people in it. For example, so there's people, there's a lot of other animals, but there's always a cat in it, so it's still considered as a cat. So there's a lot of technique to handle these problems. The deep learning or the neural network is really designed to handle those things.
Well,
So there's no need to pre-process your images. The
yeah.
thing that you might need to do is actually the complete opposite, which is, for example, to try to tweak your images, try to blur them, try to inverse them, try to do random things on them, to because when having a training data, for example, of images, we are having like a small subset of real world images. For example, your model is expected to perform on in the real world. For example, you have your model, it will be deployed on, for example, on a real camera, for example, or in a security camera, for example. This security camera or this real camera will be taken tons and millions of photos, but your training, the data you have for training is really small subset of the real world data. So you have to, in a way, simulate the real world. So you have to expect that some photos will be blurred, will be not really well taken, you'll be like not really very well positioned. So you have to simulate these things, and how you can simulate this thing is by, for example, blurring your images. And as when I say blurring your images, of course you have to keep your images, the portion of good images do you have, and generate like new images which will be blurred, inversed, and all a lot of different techniques you can apply to images to have to simulate the real world images. I hope it's clear.
Well, someone said that if you are going to use deep learning features will be extracted without worries of background problems since they happen in the model, you won't be in need of POI and all extracted manually.
What do you mean by POI?
Yeah, exactly. I was going to ask. I don't know what he means. Well, if you are here, yeah, points of interest.
If you are going to use deep learning, features will be extracted without the worries of background problems since they have in the model. Actually, yes, we don't have in model these. W- it's not the model who handles the background. It's up to us as an engineer to find solutions. Um, and actually, yes, the model works better to handle these, but I think for the key factor of, for example, neural networks is the amount of loops we are going through our data, and that amount of loop. And for example, we're every time we're trying to calculate the error, it will somehow and some way force the model to really like concentrate on really small parts of the image, and these small parts of the image, it's where your target is situated. So your background is not really relevant.
So, is everything clear, everyone? Do you have any more questions about this topic? Well, I think it's all clear. There are no more questions. Well, I just said, first of all, thanks a lot. It was a great session. I have a question for you. If it's possible, of course, I'm wondering, how did you become a GitHub ambassador in Algeria?
Okay, I can answer for that. So, first of all, what is GitHub Campus Expert Program? It's like GitHub. It's a program um, organized by GitHub. GitHub, it's a company that um, that will try to. Um, so it's a company that used a lot by software engineers. It is actually what we call a control version. It produces what we call control version system. A control version system is basically like a tool that we use to control the versions of our code. So this company has what we call GitHub Campus Expert Program, and they select like uh, 200 to 2050 people around the world to as what we call campus expert, and they are expected to, for example, be efficient at handling Git and GitHub, and to provide training mentorship to their communities, and obviously in exchange of support from GitHub in for example, in organizing events and organizing sessions and training.
Sorry, Ayman, for the interruption, but
Yeah.
Mariam said, can you please explain this in French too? As can you mix the explanation?
Okay. Yes. Yes. I agree with you. Je suis d'accord.
Yeah, if you can, please.
Yeah, c'est plus intéressant parce que ouais. Yeah. Ok. Bon. GitHub وشنو هي GitHub bon c'est une organisation c'est plus destiné pour les يخدموا software engineers راح تعاونهم في اسمه شنو نقولوا control version تاع الكود تما تقدر تكونترولي به لي فيرسيون تاع الكود تاعك تما اذا باغ اكزومبل راني نخدم بجيت باغ اكزومبل جيت هذا شغل هذا مخدوم اسمه تول تاع جيت هاب راح يخليني باغ اكزومبل يخليني باغ اكزومبل نكونترولي الفيرسيون تاع الكود تاعي اذا حبيت باغ اكزومبل نروح لا فيرسيون قديمه نقدر نروح تما هذا هو التول وجيت هاب هو از ات ستيتس اتس ا هاب تما يو كود تقدر تخلي لي بروجي تاعك باغ اكزومبل في جيت هاب it will be accessible for everyone. So now we'll talk about GitHub education. GitHub education, first of all, GitHub education, it's a space where it's a programmed, plus destiné pour les étudiants. Bon, la chose la plus importante ou bon, quelque chose que GitHub offre, c'est ce qu'on appelle Student Developer Pack. Student Developer Pack, c'est destiné pour les étudiants. C'est un pack avec plusieurs outils, bien sûr, plusieurs outils là يسحقهم un développeur. Bon, plusieurs outils, bien sûr, payants. Et bien sûr, puisque vous êtes des étudiants, حيعطيهم لك بطل. Et bien sûr, كيفاش تجيبهم bien sûr عندك bien sûr un formulaire à remplir لازم تبروفي بلي vous êtes bien un étudiant تما formulaire راح يكون par exemple تبعت له par exemple un scan تاع باليش تاع la carte d'étudiant ولا تما هذا it's really important. انا for example ما نقدرش نخدم بلا شغل ما نقدرش نروح نقدر نيماجيني بلا هذا الباك باسكو كاين بزاف لي زوتي هنايا بايون اللي يعطوهم لك باغ اكزومبل معليش باغ اكزومبل جيت برينز هذا ستا ايديتور دو كود بون كاين ناس بزاف راهم كراكيينو مي بون كاين هنايا هذا يمدوه لك باغ اكزومبل يمدوه لك طون كو فوز ات ان ايتيديون راح تخدم به باغ اكزومبل كانفا جو بونس ما كانش بون كانفا شغل تقدر دير بزاف به فايس بزاف زعما عيبه اللي يخدموا بزاف بون تقدر ديزايني به باغ اكزومبل everything related to graphics و design هذه شرايح كانفا تسمى تستحقوا بزاف كانفا بون name.com هذو اللعيبه اللي يخدموا لي هوستي واسمه لي هوستي ولي سيت ويب كاع يديك تستحقوا Yes, راح يعطيك domain one free راح يعطيك one free year domain registration تسمى عندك 1 year تقدر تجيب فيه free domains عندك مايكروسوفت ازور بيان سور اللي يسحقوا باغ اكزومبل يديبلويو في الكلاود يعطي لك 100 دولار في ازور تقدر تخدم بهم مايكروسوفت فيجوال ستوديو Bon, واش حاطي لك 200 credit for the first month. بون ديجيتال اوشن فيه كيف تقدر تخدم تهوستي في الكلاود يعطي لك $100. بون كاين فاني هذا تاع دومينز فور اكزامبل داتا كامب اللي يحبوا يدو يعطي لك 3 month free courses في داتا كامب. StreamYard bon it's really used for to stream for example حبي ستريمي في يوتيوب في فيسبوك يعطيك كاين بزاف ناس يخدموا في StreamYard. جيت كراكن اسمه جيت كراكن شغل راهو شغل قلنا جيت هاب يخدم تول اسمه جيت هذا يعطيك كنترول فيرجن. جيت كراكن تقدروا بلوس اون انترفاس فيزوال راح تساعدك. كاين بزاف لي بون مونغو دي بي باز دو دوني هنا يقدر تخدم به. كاين بزاف لي زوتي bon I can't really go all
Very
all
interesting, yeah.
yeah it's
Well,
really
Sami قال لك student pack il est renouvelable or is it a one time only?
non renouvelable tant que vous êtes un étudiant. تما tant que chaque année تقدر تبروفي باللي راك étudiant يرونوفليه لك.
Yeah. Well, thank you for sharing this. It's very well needed.
مازال ما كملت لا كيسيون تاع بون هي قالت لك what is GitHub Campus Expert. دوكا نرجع ل GitHub Campus Expert. So GitHub Expert is another program. So it's a program تقدر يسوى as an ambassador program. كاين بزاف لي بروغرام في تاع ambassadors. كاين تاع مايكروسوفت كاين تاع كاين تاع وكاين تاع جيت هاب كاين تاع مايكروسوفت
امازون
يس كاين تاع امازون. بون لا ديفيرونس تاع جيت هاب البروغرام تاعهم سي ان تي بو ديفيرون. وعلاش شغل باغ اكزومبل تحكمي البروغرام تاع مايكروسوفت they accept a lot of people and they do not offer really a lot of benefits. They're simply using the student to باش جوستومون باش ما باليش باغ اكزومبل باش يديروا لهم لا بوبليسيتي لي زوتي تاعهم سون فريمون شغل دوني على لا كوميونيتي تاعهم بلوتو لي زامباسادور تاعهم. ما كاينش فريمون بوكو دوبورتونيتي باغ اكزومبل يس باغ اكزومبل ياكسبتيوك as GitHub Campus Expert you will be selected. Yes you will be عندك bien sûr la responsabilité باغ اكزومبل تاع باغ اكزومبل دير ترينينغ و mentorship باغ اكزومبل لا كوميونيتي تاعك. وهما ان اكسشينج راح يسبورتيوك باغ اكزومبل عندك ان ايفينمون قادر يسبونسوريزيوك. they could also قادر يبعثوك باغ اكزومبل دي برايزز ولا يقدروا يبعثوا لك باغ اكزومبل ميرش هو شغل باغ اكزومبل دي ستيكرز ولا هذوك العفايس اللي تقدر تستحقهم في ان ايفينمون ولا يسبونسوريزوك دو مانيير ديريكت افيك ان بودجي. تما هذه هي. and ثاني GitHub كي بون كي when you become a GitHub Campus Expert دونك راح بون راح طونك تاع ان étudiant راح تبقى GitHub Campus Expert تما حتى تتخرج. بون الابليكيشن يفتحوها شاك 6 mois ونورمالمون راهم فتحوها نورمالمون راح تغلق لو 27 نورمالمون 27 فيفري تغلق لابليكاسيون تو لو اسمه هذه application to become a GitHub Campus Expert. So I think it's really important for communities. C'est vraiment très important باش des membres هكذا في la communauté bon اللي هم actifs surtout في des communautés هكذا تاع des clubs scientifiques ولا باش يابلايو. Vraiment, ça aide beaucoup. Parce que vraiment, genre, le programme HADA comparant les autres, ça aide vraiment les communautés comparant les autres.
Okay.
So, encourage your community members to apply.
Yeah. Well, are you reading the chat?
Yes. بس ما فهمتش تقول لي نخلي مايكروسوفت ما فهمتش.
Parce qu'à un moment donné, Zama, tu nous as dit par rapport à Microsoft, on va dire pour واحد بصح مليح, alors que les autres, ils leur donnent pas accès à beaucoup de quoi. Ah, ça, on va choisir GitHub.
Non, parce que أنا فاني bon, je suis فاني راني فاني مع Microsoft, mais
ما والو بصح.
bon, genre, ça fait 2 années, mais شغل vraiment ما تقناش، ما كاين والو.
للأسف.
بالاسم ما كاين والو.
So I think GitHub is a part of Microsoft normalement.
Yes, it's owned by Microsoft, بصح
Yeah.
راهي totally independent شغل عندهم CEO قاعد.
Yeah. So I think that's it. Je parlais du programme. What do you mean?
بارك في الفوق في الشات. Yes.
Yeah. Les deux programmes différents. Okay. Thank you so much, Emma, for today, said Joanna.
Yeah, thank you too for hosting me. It was really a pleasure.
Yeah.
Yes, so thank you.
We're so glad to have you. It was a very interesting topic. Like you did, like organize it real well, and we did all benefit from it.
Yes, I would also like to thank everyone present here. So for their questions and for their enthusiasm to learn more. So this is
We're so glad to have you guys. Yeah. So yeah, bonne soirée, and thanks again.
Yeah, thank you, and yeah, bonne soirée à toutes. Ça.
Yeah.
Toutes, c'est ça. Salam.
Merci.